Good morning, everyone. My name is Polly Sturgeon, and I am the Outreach Coordinator for the Indiana Geological and Water Survey. Thank you for joining me this morning. This is one of our Dig Deeper webinar series. This is a distance learning webinar series designed to connect K-12 students with geoscience research and careers. This program is being recorded, and I will post the live recording on our YouTube page, as well as the Indiana Geological and Water Survey's website. Links to both of those will also be followed up on the Facebook event page for today's webinar. If you have any questions for me or our presenter today, feel free to put those into the chat, and we will be sure to answer them by the end of today's program. Today, we are having an introduction to rare earth elements by Dr. Maria Mastalerz. She is a coal geologist here at the Indiana Geological and Water Survey, and she's going to do a really great job at explaining these critical minerals and the research that we're doing around them here at the survey. Today's program is best aligned with high school curriculum standards for the Indiana State Curriculum Standards, and I will post the relevant curriculum standards in that YouTube page later on today. All right, with that, I am gonna invite Maria to turn on her camera and we can share her screen. One second while we figure this out. Okay. Hello, Maria.
Hello, good morning, everyone. And I will share my screen.
Great, thank you. Thank you for joining us too.
And share the screen. Do you see my screen?
Yes, you are ready to go.
Okay, thank you so much. Yes, so as Polly said, I am a geologist at Indiana Geological and Water Survey, and I am at Indiana University. And I've been here for 27 years doing research on various topics, energy mainly related topics. And today I'm just going to tell you about one direction that we are working here on research, and that's about rare earth elements and how that can be related to the resource that we have here in Indiana. So what we are going to do, I'm just going to first have introduction to what rare elements are, why they are important. And after that, we will just be talking some more about Indiana and what resources we have that may have rare earth elements. So what are rare earth elements? So rare earth elements is a collection of 17 chemical elements in periodic table, and you have them here, plus, so these are lanthanides, and in addition, we include yttrium and scandium. These are rare, we call them rare earth elements, but actually they are not as rare as it appears from their name. It's just what it's rare, that it's difficult to find them in large concentrations. And they have very specific properties that are very important. And we can divide them into lighter rare earth elements and heavier rare earth elements. And as I mentioned, these are very important. For example, Japanese call them the seeds of technology. And US Department of Energy calls them technology metals. Why are they so important? This is busy slide show a lot of things that that use rare earth elements. For example, headphones, GPS, rechargeable batteries, aircrafts, color display in TV, cell phones, goggles, parts of cars, parts of windmills, fluorescent lamps. So you can see that these really modern gadgets, all of them use rare earth elements. And we can say that the development, technological development of countries, of nations, depend these days on the availability of rare earth elements. So that's why they are so important. Now, who has rare earth elements? Where can we find them? So in total, we evaluate, geologists evaluate that we have about, in the world, 120 million metric tons. Obviously, these numbers are not very precise because we often don't know places that they exist, and we often evaluate how much we have is really difficult. But which countries have most of rare earth elements? China, that's the leader. Then we have Vietnam, Brazil, Russia, South Africa, India, Australia, Greenland, and here, United States. So what you see here, that compared to the total availability, we in our country, we don't have much of that. So what does that mean? That means that we have to import most of them. And that means that putting a lot of money, paying a lot of money to bring them from different countries. This is a very interesting slide, a little bit complicated, but I will try to explain, that shows the history of production of rare earth elements in the world. So what you see here, this red area, this is the production of rare earth elements between 1985 till now. This red part, that's China. So what you see, that China is the global producer and pretty much global leader, and also can set the prices, can set the export restrictions. So it really has almost monopoly for production, distribution, and prices. Then the United States, this is the blue part. So what you see, that we had some production between 1985 and 2000, and we actually had one mine in California that we produced that from. Then here production ceased, we didn't have, and we reopened last years. So what you can see here, that even in China production, there is quite a bit of fluctuation here. And for example, here in 2010, China introduces export restrictions, pushing rare elements prices to records high and fueling investments in other countries. So obviously, being so dependent on rare earth elements from China, other countries are looking for new sources to make this dependence on Chinese imports lower. So this is a very, as I said, very important slide to understand what problem we have with rare earth elements. And having with all the gadgets that we have to have rare elements production and availability for all those that I show on the previous slide, And now, knowing how little we produce, we are really dependent on the import. And that's why the United States government over the last several years also kind of supports the search or research into searching for new sources of rare earth elements. Now, where do they occur? Where can we find these rare earth elements? We can find them in rocks. That's the main source. Now, rocks can be very different, of different origin. So most of rare elements we can find in magmatic rocks, in rocks that were formed at deep in the subsurface at high temperatures, high pressures. So these are kind of magmatic and also metamorphic rocks. So igneous rocks, carbonatites, igneous rocks, and only small percent can be found in other rocks, in kind of more soft rocks, in sedimentary rocks. And but we also have to remember that we really have not searched for those rare elements in other than magmatic rocks, really in details. So that's why we will be concentrating in the rest of the presentation on those rocks that we actually haven't looked that precisely as sources of rare earth elements, but they can be new, that could be a new resource. So kind of to summarize what I just said, the traditional sources of rare earth elements are usually magmatic rocks, crystallized and high temperatures, deep within the earth. And because there is such a demand for rare elements, because of these new technological devices that we produce, that everybody uses these days, those traditional sources become progressively depleted. So that's why we really need to look for new sources. And one of those new sources that people have been looking at are coal and coal-related products. And so now I'm just going to tell you a little bit, what can we expect from those coal and coal-related products with regard to rare earth elements. You probably all know that Indiana is coal producing state. We produce coal starting around 1880, and this diagram shows production of coal in Indiana from 1880 till now. And this is red are surface mines, production from surface mines. Blue is production from underground mines, and total mining, that's surface plus underground added together. So you can see that right now we are at 30 million tons a year producing coal in Indiana. And we produce, as you see, for many, many years. So now, when we produce coal, when we mine coal, and remembering that we mine every year about 30 million tons, that's quite a bit. When we mine coal, then this coal, most of Indiana coal is washed. We want to wash the coal because we want to have relatively clean coal. We want to get rid of those components that don't burn that well. So we send our coal from coal mines to coal preparation plants for processing. So in coal preparation plants, what we do, we wash the coal and we get cleaner coal product. And also we can get coal waste that it's not as good for combustion, for gasification, for any applications. So what those coal preparation plants do, that they have bunch of material of that it's called reject, that it's coal waste. And usually this coal waste is deposited close to coal preparation plants in some ponds or also in some gobs, in some piles. So there is quite a bit of that material. And then when we have this clean coal from coal preparation plant, then such coal is being sent to the client that it's utilities. These are coal-fired generated power plants. So they get this clean coal and they burn coal, for example, to produce electricity. So they burn the coal, and so they get the electricity from it, but there is a residue that actually did not burn, and that's called ash. And so every year, those coal preparation plants, they have a lot of ash that it's left from burning of the coal. And those coal ashes also are kind of piled often in some ponds next to coal preparation into power generation systems, so close to utilities. So there are piles, there are acres of those coal ashes that stay there, and some people see that as a hazard because if they get in wet environment, there can be some leaching going on, some dissolution of some elements, then can contaminate, for example, water, so contaminate soil. So there is some bad part of that if they stay in the place. Some of that material is being used, for example, for roads or for producing cement, but a lot of that is still in that next to those utilities. So thinking about coal mining, coal preparation, and power generation systems, in all these parts, we can have rare earth elements enrichment. So instead of being a bad kind of material that sits there, potentially, perhaps we can use them, process them, and extract rare earth elements for all those various purposes. So here at Indiana University, we've been working on looking at coal waste, and coal ash as a resource for rare earth elements. This is, and I will show you some data, try to make it as kind of simple as possible. We, starting with coal. I said that in Indiana produces quite a bit of coal. We produce for years. We have lots of coal beds, and these are those in red here on this diagram that are being mined and were mined for years. So we in Indiana, this is part of Southwest Indiana, and these stars here, these are the places that we collected coal to analyze for rare earth elements, because perhaps we can identify some coals that are enriched, and then we really can use those coals as resource. So now I'm just going to show you a diagram that shows rare elements concentrations. And this is an example of coal mine, surface coal mine in Indiana. And this is my colleague here and myself happy to collect some fresh coal. And here is a coal preparation plant that produces this clean coal but on the other hand, leaves that coal waste. So coming back to our data that we looked at various coal beds in Indiana, and here are the data, and this is in parts per million, ppm. And the only thing that I want you to notice from that there is variation, that some coals have a lot of that, and some coals have much less of rare earth elements. So immediately we noticed and that some coals that we identify, and we know where they are, we know who mines them, can be better resource for rare elements than some other coals. So that's already a good kind of suggestion, a good guide for us that some coals have 3 times as much rare earth elements than some other coals. So now, how can we say that our rare earth elements in coal, let's say, are good quality or they are potential? And there are several ways to evaluate that. And here is, I am showing you one of the ways that we evaluate that we look at percentage of those rare earth elements that are more important in the market, that they are higher price, we pay higher price for them, they are of higher demand. And then we put them on a diagram, and then we kind of look at how much of them they have compared to the whole number, to the whole concentration of total rare earth elements. So here we put our coals on this diagram, and the better, the higher on the diagram, this is most promising. And in addition, we also put on this diagram some world-known mines or places that rare earth elements are mined. So they are from Vietnam, they are from China, and our coals. So you can see this is some Chinese, these are also some Vietnamese. So you can see that the quality of rare elements that we have, it's not actually worse than some other places. So we really need to look at them in more details, because perhaps we have a new potential source. This is another way to look how good rare elements concentration is, and this is based on concentration. So when we think about that, we compare rare element concentration in our samples to, for example, standard value that we have in the earth. So in this way, when we divide this, we compare this, we can talk about enrichment. So for example, if we have enrichment of 10 times in some rocks compared to typical in the earth crust, we're happy. If we have 1,000 enrichment, that's a huge resource. So this is, as I said, the other way to evaluate that based on concentration. And again, on this diagram, I compared some Chinese clays. I compared our coals. These are the red one and this orange one, and some other rocks. So again, we are not at very high enrichment, but we're not bad. So that's kind of an encouraging thing. So this was the coal. Now, I told you that coal is being set to prep plants, to preparation plants, where we have two major fractions: clean coal that goes to utilities, and then the waste fraction. The waste fraction, that's the one that doesn't have that much coal. It has a lot of mineral matter. It's a rock. It's a kind of it's a clay. It's a calcite. These are the rock pieces that will not burn. So in preparation plant, we just remove them and sit on the pile, sit on the gob. So in our research, we compared those fractions. We compared coal from the mine, and then we compared clean coal, and then we compared waste from that coal in terms of rare earth elements. And here, for example, there is an example of one of them. It's cerium. Look at that. And so what we see from here, the highest cerium content sits in this refuse, in this waste, and the smallest is in the clean coal, and raw is in between. That's the coal from the mine. And so what it suggests to us that actually probably those rare earth elements sit in the rock, in mineral matter, not in this coal organic fraction that it's being cleaned, you know. So that means that if we look at those piles, they are already there is much increase compared to the original coal. So here is obvious resource that we already have enrichment that otherwise wouldn't be used. And we can actually look at that, and perhaps again we have acres and millions of cubic meters of that material sitting here in Indiana. This is another example of yttrium. Yttrium is another of those rare earth elements. And again, this is yttrium concentration going up, increasing this way. What we see the same history. We see the same story, that this waste is significantly enriched compared to the clean coal or the raw coal from the mine. So these relationships already are telling us, hey, we need to look at that coal waste because there is a concentration. As I mentioned, in Indiana, we have a lot of coal preparation plants because we mine our coal over hundreds of years. And this is a map of some Indiana counties, and all those places, those spots on the map, these are coal preparation plants. Then we have this waste material lying there, either as a gob or kind of pile, or as a coal slurry ponds. And then we have more than 200 deposits of slurry, more than 200 deposits of gobs, many hectares, lots of volume of that material that needs to be researched as a rare earth element source. Now, that was coal waste. That was what sits next to coal preparation plants, places. Now, I mentioned that from coal preparation plant, we have this clean coal product, then goes into coal-fired power plants. That's a different place. So it goes there, it's being burned there for electricity, and the residue, that's coal ash. So coal ash is nothing more than mineral matter in coal, because it doesn't burn. You know, what doesn't burn, it's kind of ash, and mineral matter, that's the one that does not burn. So again, in Indiana, we have a lot of acres of coal ash deposits, and we have a lot of cubic meters of that material that it's lying there, and again, needs to be researched. We don't have that many data on rare earth elements from ash, but what we know that coal ash is mineral matter. And we already, from coal waste, we know that there is a concentration of rare earth elements in that rock, in mineral matter. So again, in coal ash, we expect large concentration of that rare earth elements because the clean organic fraction, clear core fraction was burned and transformed into electricity. And here is an example of rare elements in coal ash. Just we don't have many data, but I just wanted to show you some. And I mentioned that one of the ways we evaluate that when we look at enrichment, how much in our material we have more of that those rare elements compared to, for example, typical air crust. And here is enrichment compared to a relationship between rare elements and chondrite. So you can see that some samples of coal ash have up to almost 1,000 enrichment of rare earth elements compared to chondrite. So it's a huge unexplored resource that we have here in Indiana that can be used for that purpose. And so kind of talking about coal ash, we currently we have a project that is supported by Department of Energy that we are looking at how much actually coal ash is available, and we are collecting some samples of that ash to get more data on rare earth elements. And then eventually, hopefully after a couple of years, we will be able really to come up with assessment how much of rare elements we can extract. Okay, and the last thing that I wanted to mention about those coal-related materials are acid mine drainage. You probably heard that term, acid mine drainage. If we have, for example, coal waste sitting in a gob or sitting in a slurry, and it happens that it's wet, it's mixed with water, it's a wet environment, as I mentioned, it can leach. And those leaching, those waters that come off that material from those piles related to coal mining activity, it can be enriched in, it could be acidic, it can be enriched in some rare elements, and also it can be enriched in rare earth elements. So acid mine drainage places, it's another place that we are looking at concentrations of rare earth elements. And this is usually liquid. So because it's in a dissolved form, it can easily be extracted. While from the solid material, it's difficult to extract rare elements because they are just so dispersed. From acid mine drainage, from the liquid, it could be much easier extracted. So again, we are looking at, in Indiana, we have quite a few places of the acid mine drainage that we researched for years in terms of biological activity, as bioreactors, as influence on surface and underground waters. But we don't have that many data on rare earth elements. We do have some, and we do see that some of them have much more than some other places. So it's again, we want to identify what characteristics these places have that we can use to kind of to see to determine where the sweet spots for rare elements are, because that's actually the goal for us. Now, in general, analyzing rare earth elements is not an easy process, and not every place has ability to do that. It requires dissolution of rock, it requires specialized instrumentation, because they do occur in very, as you saw, in ppm, parts per million quantities. So these are small amounts. So we have to be really, you have to really use precise instrumentation. So one of the things that we want to do, we want to find some parameters in the rock, in coal waste, in coal waste, in coal ash, in acid mine drainage, that we can analyze easily and then use as proxy. So perhaps there are some components that we routinely measure. For example, pH, for example, content of ash alone, for example, content of mineral matter, that we analyze all the time. And perhaps there are some relationships that can tell us that, okay, if we have more, for example, aluminum oxide, then we can have more rare earth elements. So that's another thing that we really are looking at such relationships, generating more data. But for those relationships to establish them, we really need quite a bit of data so that we can statistically actually evaluate. And we recently actually employed statistical analysis and machine learning actually to our databases on coal, try to identify promising and non-promising areas. And we just kind of submitted a paper actually last night on that to an international journal, that we, based on some parameters, ash content and aluminum oxide content, we can identify promising and non-promising areas of rare earth elements. And this is what we want to see. We just need more data for for that purpose. So it's that's pretty much, we are coming here close to the end of my talk. So thinking about future of rare earth elements, what can we expect? We can expect several things. We can expect increasing demand from end-use industries. We know everybody wants to have cell phones, everybody uses computers. We use lamps, we use batteries, and these uses will only increase. So we need more. That's the increasing demand. That's one of the things that we expect. Two, remembering that China is still the main producer and sets the prices, sets the export strategies. We expect fluctuating costs of rare earth metals because of China's overwhelming dominance of rare earth elements markets. We do expect that there will be some new mines because there is lots of research in many countries going on to find new places and new processing plants and new extraction technologies. Extraction of rare earth elements is a difficult task. And a lot of money is put by our government and our governments into finding new ways to extract, finding those technologies, developing that are less costly, because that would really make a difference. And the number 4, we expect to push to reduce amounts of rare earth metals in products. I mean, perhaps we will look for some replacements because some rare elements are very expensive. So we expect that. Then we expect higher recycling and reuse. Can we reuse somehow rare earth metals? Can we reuse and recycle those gadgets that we are using so that we can somehow get those rare elements from them. And again, for next decade at least, we expect that Asia Pacific is projected to hold still the largest share. So we will be dependent to a large extent on those markets. But again, like research that we are doing in Indiana, it's very needed, needs more support. And especially here in our state, that we have so much of this coal waste material and coal ash that it's sitting there kind of unused and really kind of it's even sometimes harmful. So yeah, so this is the project that we probably will be working on for next, I expect, at least couple or several years, and hopefully the project will result in some good data, good recommendations that I hope will make difference for Indiana, for our state. So yeah, thank you very much. And if you have any questions, comments, happy to entertain.
I'm not, I was muted, excuse me. Thank you, Maria. That was such a wonderful presentation. I think I learned a lot, even though I've heard you talk about this before. And we have several questions that have come in from our participants, and I'm going to read off some of those. If anyone thinks of any other questions, feel free to just add those to the chat. You can send them to everyone or directly to me, and I will make sure they get answered. Okay, the first question that we received: why is there only one rare earth mine in the US, the one in California?
Mm-hmm. Yeah, because in the States, we really don't have those carbonatite rocks that they are not common. Mm-hmm. So this is one of the few places that actually there is. And you know, the mining that they were doing there also, you know, in the States, we have strict environmental regulations, and the mine was at some point had environmental problems, didn't pass some regulations, so it was actually closed, you know, and now recently reopened because there is such a demand and such a need. But this is this traditional source of rare elements that we have in California. It's those carbonatite rocks. As I said, they are rare. So we have to look for new sources, and new sources. That means if we explode old sources, we know how to do it. We know how to extract. If we look into new sources, we are not so good with extraction. So we have to develop extraction technologies, and that takes time. Okay. Great.
Another question kind of about the basics of how these critical minerals are used. Do all computers use rare earth elements, or are there some that do not?
All computers use, all screens right now use those rare earth elements, yes. Okay. If you have a color screen, it's just, yeah.
So a very needed resource.
Yeah, very needed. And cell phones as well.
Yeah, we use it all the time, every day. Okay. You shared one graph of annual coal production in Indiana, and someone noticed that starting around 2010, surface mining started to go down and underground mining started to come up. So not related necessarily to rare earths, but they wanted to know why was there that switch around 2010?
Yeah, it's a good question. In Indiana, we are at close to the boundary of the basin. So a lot of coals are very close to the surface. And those coals, we had a surface mining for many years and used those coals that are closer to the surface in surface mining. So they are really, we don't have that many of those shallow coals left for mining, but we do still have a lot of underground mining. So our Indiana mining, if we are going to mine, we are going to use that underground, deeper resource that we still have. And that's why we are really switching, and it's a good observation. We are switching for surface mining to underground mining more to use that unexploited and unused resource yet. And you probably also noticed that at the beginning we did underground mining, and then we switched into surface almost to large extent. Now surface is depleted.
Great. Yeah, I thought that was a really great question.
Yeah.
Someone asked, what happens to coal waste? Are there any other uses for it besides what you're studying?
Yeah. Some of that is used for roads because, you know, it's a aggregate, it's a stone but otherwise it's pretty much coal waste. Pretty much it stays in tailings, and it stays in ponds and in gobs. With now with in terms of coal ash, I think about 50% coal ash in the United States is being used, and is being used for in production of cement, is being used in production of also for roads and for other uses, but still 50%. It stays where, you know, just next to the coal-fired power plant.
This is waste. Yeah. So
it's waste. So if we could utilize that somehow, that would be just a win-win situation for everybody.
Yeah, absolutely. A really good question. Would extracting rare earths from coal waste cause any new mines to open?
If we extracting rare earth elements from sedimentary rocks, it's not an easy process yet. So, but there are several projects, relatively large scale projects that are being worked on right now. And I think that if not in a few, but in several years, we will be really good with extraction, but we are not there yet. Mm-hmm. This is from both from coal waste and from coal ash, because it will be pretty similar extraction technique. But if that happens, I think we have to wait for this breakthrough in extraction process that probably would open this resource for utilization. Now, would that mean we would open new mines? Not necessarily, because we have millions of stuff sitting there right now. So we probably would start with the ponds and gobs that sit over there right now, rather than just to go into mining. Yeah. And generate more of that stuff. The stuff is lying there. It's already kind of soft, you know. Mm-hmm. So I don't think it will result in opening new mines. I think new mines, it's, you know, coal production is going down in the States is going down because of, you know, various reasons, switching to gas, politics, and lots of other, you know, so there are lots of other factors that influence that.
Yeah, so not opening new mines, but just reusing waste. It's not being.
Yeah, that would be the first step. Yeah.
Okay. You had mentioned that it's good to be looking at these reuse or kind of alternative methods for extracting rare earth elements. Are there any other states or countries looking at coal waste and coal ash as a potential resource?
Mm-hmm. Yeah, it's last probably 10-15 years, lots of countries are looking at that. Lots of countries, and coal ash and coal waste, these are the obvious targets for that. China is looking, Poland is looking, India is looking, all those coal producing countries, they are looking. But again, looking, it's because there are no these data available. It's a kind of a new demand
Mhm.
over last decade or two, you know, data are not available. So in order to actually assess the available resource and viability of that as industrial scale resource, just takes time. So yeah, a lot of people are working on it, but as I said, extraction and processes are too costly yet, not really there yet in all the technology for that. But yeah, everybody, lots of looking, all coal mining countries are looking, because all of them have a lot of waste.
Mhm.
And there is major need for all of them for rare elements, and everybody depends on Chinese supply.
Okay. Kind of a similar question. Are there any other deposits other than coal related deposits being researched as potential sources?
Yeah, there are, and also we within here with Indiana Geological and Water Survey, we were looking at some other sedimentary rocks. Like in Indiana, we have beautiful sedimentary rocks. We don't have really magmatic rocks or metamorphic rocks, so we need to work with what we have. But one of the obvious sources for rare elements are phosphates. So any rocks that contain phosphates are a major target as well. So for example, we are looking at phosphate-rich or phosphorites in shale sequences, in Devonian sequences, in Ordovician sequences here in Indiana. And we actually identified that those rare elements concentrations and resource that we have in phosphates in sedimentary rocks, it's higher than anything. But again, sedimentary rocks, we are not there yet with inexpensive extraction. With extraction that we know how to we have to pre-concentrate, and we have to extract, and that's still a developing process.
Okay, got 3 more questions right now. So you mentioned that the extraction is a difficult process. Somebody asked, how are they extracted?
Yeah, so the first thing, I mean, it's a complex process. First, we have to pre-concentrate. So we have to crush the rock, and we have to often magnetically to extract some fractions and pre-concentrate them to, let's say, 2% of rare earth elements, which is already a very difficult process, because if you have 800 ppm and to pre-concentrate parts per million and to pre-concentrate them to 2% is already a lot of doing. Now, when we have this pre-concentrated, then we do various sequential extractions that we remove one fraction using one acid, another fraction using another acid, third fraction using some oxide mixture with something. So we do sequential extraction until we just left with rare earth elements. So it's and there are various techniques, and people try various things. They try to use some biology, some bacteria, some also to help with that. So various kind of different ways, membranes and physical and chemical and biological, all of that is being tried.
Really interesting. I didn't know about the biological methods. That's neat.
Yeah, they do. Yeah. Mm-hmm.
Okay, someone asked about how is carbonatite formed, the igneous deposits.
Yeah, it's a rock rich in carbonate that actually it's formed deep at it's a magmatic rock that it's crystallized from the liquid magma, at some temperature, probably 700 degrees centigrade or 800 degrees centigrade or more, at some pressure regime, and with a magma that it's rich in Ca and it's just crystallized like many magmatic rocks at the surface. I mean, at deep subsurface. Yeah.
So high alkaline magma comes into the ground. Yeah. Okay. The last question that I've received so far is, you had mentioned that on one of your graphs, some coals have less rare earth elements that you've noticed. What is it about those coals that gives them more or less rare earth elements? Is it related to the prehistoric swamps that the coals formed in?
That's a good question. Yeah, that's a very good question. And, you know, it's because we do see in Indiana that some specific coal beds have more rare earth elements. It automatically suggests to us that the positional conditions were part of that, because other components like qualification and hydrothermal things were pretty similar in the coals. So yeah, so that's from the positional environment, and some of them comes from related to marine transgressions and bringing some mineral matter into specific mineral matter into the swamp. And we do have in Indiana quite a few coal beds that were influenced by marine waters. So yeah, this enrichment mainly comes from the depositional time during deposition, and it's related mainly to mineral matter that was brought from marine environment.
Wonderful. Thank you for answering.
That's what I think.
Thank you for all these questions. Yeah. Well, you're the expert. The director of our state survey, he always likes to say that Maria has won every award related to coal geology except for the one that will someday be named in her honor. So we really thank you for your time. You're such a wonderful speaker. Somebody asked, when will this recording be available? I will get this posted to YouTube with closed captionings by this afternoon, and then links to that YouTube video will be available on our website and our social media pages by the end of the day. This is the 5th in the series of Dig Deeper webinars. This will be about 2 webinars more related to high school curriculum standards, 2 so far related to middle school, and 1 related to elementary school standards. Of course, that can be scaled up or down and obviously relate to adult audiences as well. But if there are any research topics that you're interested in hearing more about from our scientists, please let me know and we can get that scheduled. With this, I think that's the end of the program. Thank you again, Maria, for all of your time and expertise. And thank you to all of our participants for joining in. I hope you enjoyed this, and we'll hope to see you again in the future. Bye-bye.
Thank you. Bye-bye.